Hello everyone, this is the video lecture for College Algebra Math 1414 Section 4.3 Properties of Logs. So we learned about logs last time, now we're going to be manipulating them. I want to use the word simplify. When I say the word simplify, you think all kind of things. And so that's what we're doing here. That's the point of this section is I want to simplify. But I want to make a point to you about what simplify is. If I were to give you something that looked like this, and I said simplify, then you would probably end up doing something like that in the end. Okay? But what if I had started with this guy here, and I said simplify, and you might end up with something like this. You might also be confused because it's already simplified. But the point is that neither of these are wrong. I'm using the word simplify because it's kind of a vague, general, I don't really know what you're wanting kind of thing. I just need to do something with it, and that's kind of what we're going to do here. We're going to be doing stuff with logs. So let me give you some formulas. They call them rules, but that's fine. So we got the product rule. The product rule of logs. I've got log base b of m times n is equal to log base b of m plus log base b of n. Now, what I'm doing here is I'm expanding. That's a version of simplify, I guess. Expansion. Close enough. Expansion. So I'm making a times on the inside into a plus sign on the outside. I'm taking these two terms and I'm splitting them up into their own separate logs. This is a legal move. This is okay. Like, let's do a quick example. Let's say I've got log of 2x. Well, then I can split this up as log 2 plus log x. Now, is that helpful? Is this more simplified? I mean, I don't know. What if I had started with this and I wanted to go backwards? Is that more simplified? I don't know. The point here is not that we're going to try to get one particular goal here, but that we have to manipulate it according to what they're wanting. If they give you this, go find that thing. If they give you this, go find that thing. That's essentially what's going to go on. All right. And if it all seems confusing, I'm just going to be doing some problems here in a minute, and you'll totally understand. So I've got log base b of m divided by n is now equal to log base b of m minus log base b of n. This is called quotient rule of logs. So again, we had a quotient, and I'm going to split it up as a minus sign on the outside. Quick example. Let's say that I have log of 7 over y. Well, now I've got log of 7 minus log of y. Very simple. And the last one, power rule. Power rule, we got log base b of m to the p power is equal to p times log base b of m. And so this p power comes to the front. Whatever power you have on the inside of a log, you can bring it out to the front as a multiplier. Let's do another example. Let's say that I have log of x cubed. What you could do is take that 3 and move it to the front as 3 times log x. Again, is this more simplified? Is this more simplified? What about this guy? Again, it's supposed to be a vague term. Because they're going to use the word expand or condense or something like that. And it's okay to pay attention to the words sometimes, but it's also important to just know that we need to be able to manipulate these logs any way that we need to. And so, for example, as you move on, because this is the point of this class, right? You're going to move on more math classes. When you go on to pre-cal, we'll be seeing this again, but when you move on to calculus, we'll be actually taking derivatives and integrals of all this stuff, and trying to find a derivative of this one is not very fun. That's not a good thing to do, but I can find derivatives of this stuff much easier. The point is that we're simplifying it into a form that is better suited for what we need. And it just depends on what that form is. Okay, I guess that's enough talking about that. One other thing about my examples, I didn't include any base with any of them. It does not matter what the base is as long as you keep the base all the same. Here, I don't know, let's just use a 10 because that's technically what it was already. It doesn't matter the base as long as you keep the base the same. That's why it says base B there on the formula. Okay, so 4, 3, 3. Let's do some examples. I got log base 15 of 15x. And they say expand, simplify. So I see that this is multiply, so then I can split this up as a plus sign on the outside. And basically we're done. Can I simplify some more? Can I make it a little bit easier? Yes. Notice that these 15s are going to cancel, leaving a 1 behind. We learned that from the last section. Okay. There's your answer. Turn the page. 4, 3, 9. So I've got log of y over 100,000. So, of course, that's division, so I can split this up as log y minus log of 100,000. So I need to simplify this a little bit more. I think I could do something over here. Remember that this is base 10. If it doesn't have a base, it's technically base 10. And so I'm saying 10 to what power is equal to 100,000? Did I do it enough? Yeah, okay. In a way, I'm counting how many zeros I have. 1, 2, 3, 4, 5. 5 zeros. And so you can actually simplify this down to just a 5. Now, if that's a little much, because it is, you could use a scientific calculator. There's no problem using a basic scientific calculator to get these answers sometimes. 4, 3, 15. So I have log base d of x to the 4th power. I have never seen a log base d before. I guess that's just what it is. So it's a power rule. I'm going to bring the power down to the front. 4 times log base d of x. And there you go. You got to type a base d, or otherwise they're not going to like that one. 4, 3, 19. I got ln of the 8th root of x. I think it looks just like that. Now, I'm a parentheses kind of guy, so I like to add parentheses. That 8th root on the inside is a power. It's a 1/8 power. So roots are 1 over whatever number it is. So square root is 1 over 2. Cube root is 1 over 3, etc. Oh, it's a power. So I could use power rule and bring it to the front. 1/8 times ln of x. And that is the most simplified version that we have. Okay, so those are the basic ones. Let's now jump to slightly more complicated versions. I have log base b of x cubed times y all over z squared. So I need to simplify. Yes, I need to expand. Notice that we have 3 different terms. We have the x, the y, and the z. And so I'm going to split this up. I'm going to do this the slow way, okay? First off, I see division. So I'm going to keep my numerator, and then over here, I'm going to make my denominator separate with a subtraction between them. Oh, well, this is multiply. So then I could actually split that up as well with a plus sign between them. Okay, and then this still has that minus way over here. Oh, I've got powers. I could move those down to the front of those. Oops. Let me just rewrite it over here, I guess. Kind of crunching myself all the time. And that is a 3. I don't know why I keep writing a 2. It's probably because the 2 way over there. Okay. And yes, you got to put a base B on every single one of them. Whew. All right. That takes a long time. There's got to be an easier way. There is. There is an easier way. So I want to summarize the product and quotient rule down to something much easier. The power rule is super easy. You just move the things down to the front. But this product and quotient actually can go together. Notice what I had to do in this particular problem. I did the quotient, and then I did the product, and then I did the power. Well, if you do this product and quotient in the wrong order sometimes, or maybe if they had multiple things down here but only one thing in the numerator, if you don't use parentheses properly, you will have issues. You'll have issues big time, and I don't want that to happen. I could show you a quick example. Here, let me go. This is not on my notes. I'm just going to do it because it's important here, okay? Let's say I've got a 2. I don't know. I'm just making something up. Let's do an x and a y cubed, something like that. Notice that we got multiple things in the bottom, and so then I don't like base b. That's not part of my example. I just want log. Okay, so I say, oh, there's division, so I'm going to do this. That's correct. And I say, oh, there's a multiply over there. So I'm going to put a plus sign between them. And that is no longer correct. That is no longer correct. What's wrong with this thing, other than the bad handwriting? Yeah, we do want a plus sign between them, but they've got to stay inside the parentheses. It's very important to be able to keep those parentheses straight. Then you can go ahead and distribute. And what I'm trying to get at is that if you start breaking it down like this, and then you got the power rule, that's a 3. I don't know what it is today. What you're going to do is you're going to complicate things, and look at all these steps. How many steps? And, you know, the more steps you have, the more possibility of getting it wrong. I want to simplify this for you. I think all of this is a lot. It's too much. There's an easier way that the book doesn't teach, and I want to do my own thing, okay? So I call this, I don't know, Chad's rule. I don't know, whatever you wanted to call it. Hello, my name's Chad. So what I like to use is anything in the numerator inside of the log will end up with a plus sign in the front. Anything in the denominator will end up with a minus sign in the front. So what do I mean by that? Let's do a quick example. In fact, let's do that example we had last time. It'll be pretty easy. 2 over x and then y cubed, something like that. Notice I got 3 terms here, and we would see that anyways. We got a 2, we got an x cubed. So I'm going to say log of the 2, and then I've got this log of the x, and then I've got a log of the y cubed. Now I want to know what are the signs in front of each one of those. So this 2 here, he was from the numerator. He's from the numerator. Numerator gets a plus sign in the front. This x right here, ooh, he came from denominator. And denominators, they get a minus sign in the front. What about this y cubed? Oh, he's in denominator. Denominator gets y, or a negative sign in the front. And then finally, last step is bring the 3 down. And what I've done is I made this more complicated problem, and all of its parentheses go away. It's only 2 steps, and we get to the actual correct answer almost instantaneously. So I'm going to do this style again and again and again, and, well, maybe not that many times, but I will do it again in a couple times, just to show you that numerator-denominator stuff makes it really easy, okay? In fact, I wanna do the last problem like this as well. Since we already have the answer for it, I'm just staring at it right here. We had x cubed y over z squared. I can get this thing done in 2 steps. So, first off, let's look at our terms. I have x cubed. He's in a numerator. Numerator gets a plus sign in the front. Why does he have a plus sign in the front? He came from the numerator. Ooh, we have a y here. Where is he? He's in the numerator. So he gets a plus sign in the front. Why has he got a plus sign in front? Because he came from the numerator. Ooh, we got a z squared. Where's he from? He's from denominator. Denominator, he gets a minus sign in the front. Hey, why does he have a minus sign in the front? Because he's from denominator. Last step, put your powers down in the front, pull them down to the front, and you're done. That's, well, the end of that problem. 2 steps, no issue. Again, I'm just trying to show you a lot of different practices on this. That's it. You're done. That's the end of that problem. So that was an easier problem anyways, because it didn't have a lot of complicated parentheses going on. But 4,339. Here we go, guys. Log of 10x to the 5th times the cube root of 8 minus x, and then all divided by 3 times x plus 8, all squared. Simplify. Expand. Yeah, exactly. So, okay, seriously, if you were going to go back and do it the 1-by-1 steps every time, I'm sorry for you. It'll take forever. Instead, let's use the numerator denominator with the plus sign, minus sign stuff, and it's going to be done, I'm not kidding you, 2 steps. 2 steps. And the second step is only because of the powers. If I were really clever, I can probably get it done in one step. 2 steps, I promise you 2 steps. So here we go. First off, I have a 10. Every single term. Oh, why is I put a plus sign in the front? Why has it got a plus sign in front? Because he came from the numerator. I got an x to the 5th. He's in the numerator. I put a plus sign in the front. Why is there a plus sign in front? Because he's from the numerator. I got this cube root thing. Notice he's in the numerator. So I put a plus sign in the front. Why is there a plus sign in the front? Because he came from the numerator. I'm doing this on purpose, guys. I know it's annoying. I'm doing this so that you can try to remember. And I'm making fun with it too, you know. Maybe it's not fun. But it's math and we got to do it. Hey, this 3. He's in the denominator. He gets a minus sign. Why is he get a minus sign? Because he's in the denominator. Last one. This big square thing. Denominator. Minus sign in the front. Why has he got a minus sign in front? Because he's in the denominator. Now, I'm going to try to get a little bit more room there. Notice that it's x plus 8 in parentheses squared, like that. Again, denominator. And that is step 1. We are really close to the end. So I want to simplify. This right here is a 1/3 power. That'll come to the front. This 2 will come to the front. This 5 will come to the front. Is there something else? Yes. Right here. This is base 10. All this is base 10. 10 and 10 are going to cancel, leaving a 1. 5 log x, 1/3 log of the 8 minus x. There's nothing to do here, just log 3. All right, I guess log 3. Nothing else to do there. And then we got our x plus 8. We are done. We did that whole huge problem in 2 steps. That's it. That's it. So we got to use good strategy, good methods, and don't follow the book. So next question. I didn't just say that. Yeah, I did actually. So ln of x plus ln of 10, and they say combine these. So after you do the really hard one here, hard ones, I can't remember if there's more than one, they're now wanting you to go backwards. We're going reverse. Again, I'm not kidding you. All we're doing really here is simplify. Simplify this. Go. Figure it out. Well, I mean, it's already expanded, so what they probably want us to do is combine or condense or whatever it is, make it into a single log. Notice that there's a plus sign between them. So I can simply say, there's a times sign between these guys. Yeah, that's your answer. If you want to make it look pretty, that's fine, of course. But either way would be fine. Cool. That was easy. We're just going in reverse. And if we need to, we can also use my Chad rule or whatever you want to call it. Because my name is Chad. Hello. Move the 6 up. Move the 3 up. I mean, every one of these is, hey, what do? You simplify. That's all you're doing here. It's the entire section. So powers come first, and then I say, oh, look, I got a log minus a log. You can combine them together with a division now on the inside. So you're wondering maybe, why did I have to do the powers first? Couldn't I have done the minus sign and then the powers or something? No, you've got to do the powers first. I guess in a way, we're going backwards here, right? If you look at my steps, and I'm going to go backwards now, what comes first? What's the first step if we're going backwards? Is the powers. See, I'd have to move these powers back up. Then we go and do the numerator-denominator stuff. Okay? Combine it all into a single log. So if you're going in reverse, powers come first. It's even rhymed a little bit. Haha. 4,371. I think these are different now. Yeah, this is a whole new problem. Here we go. So I got log base 13 of 11 is equal to what? Good question. So this problem, it confused me a little bit. What they want is a part A and a part B. Part A is a formula of some kind, kinda, and then part B is going to be some kind of a decimal answer of some kind. Well, I have no clue what to do here. If you went and tried to put this into a scientific calculator, some of them will do this. Some of them will do log base 13. Some of them won't. They just don't have the capability. I know I tried Desmos on this guy, and it says, we don't do log base 13, which is, like, sad. So you use GeoGebra. No, I'm playing. But the point is that not everything can do the base 13. It'll do log. It'll just do log. That's fine for it. It'll do ln. That's fine. But not the log base 13 or any of that stuff. So how do we do this? Well, there's a formula. It's called change of base. Change of base. And here it is. I'll give you the formula. Log base b of m is equal to log of m divided by log of b. We could also use the ln of m over ln of b, but I don't really much anymore. I'd say this is probably more what I'd use in calculus, but this is good enough. Everyone knows logs, so it's good enough here. Okay, this is how I'm going to rearrange it. And so in my particular case, I had 13 and an 11, which do not cancel, by the way. So then I've got to just put the 11, and then I've got the 13. And that is it. That is your answer to part A. I guess you could say it's like your exact answer. I'm just using the formula. Part B is to go in and use your calculator now, which will work because it's just log. The logs do not cancel. That is an incorrect statement. Do not do that. This is just its own number. This is a number, and you divide them, and you get a number. So I put it all at once in the calculator, and I got 0.9349. It's not too bad after that, honestly. Okay. And I've got two last problems, and these are different. They're a little confusing at first. Once you get a hang of them, they're easy. It'll say log of 7/3 is equal to what? Given that we have log of 3 is equal to k, and log of 7 is equal to h. Go. Figure it out. And I'm like, what? We can expand and simplify this down. Notice that there's a division, so now what I could do is a minus sign between them. Okay. Hey, have I seen this somewhere before? Log 7. Oh, it's right there. H. Like literally replace it with the letter H. Where have I seen this log 3 before? Is it? No, is it? Oh, it's right here. So you replace it with a K. And that is your answer. That's it. That was it. It's not hard. Kind of weird. Let's do another one like this. 4,385. So I've got log 16 is equal to what? And they say given that we have log of 2 equal to u and log of 9 equal to w. Okay. Well, I don't see any product or quotient rules. I don't see nothing. I don't know how to get 2 down to a 9. I don't know how to do that. Well, it's not 2 to a 9. I'm sorry, 16 to a 9. It's 16 to a 2. I wonder if I rewrote this as 2 to the 4th. I think it's 2 to the 4th. 2, 4, 8, 16. Yep. 2 to the 4th. But then I can move my 4 to the front. I don't know. Have I seen this log 2 somewhere on this? Is it on the last problem? No, it's right here. It's right there. 4 times u. And that is your answer. Just, it's a u. Did you use w anywhere? Did you ever see a 9? I didn't see a 9, so don't use it. That's it. They're really, really easy. It's just kind of confusing. Of course, as always, if you have any questions, please let me know. But other than that, I'm done. Thank you very much, and have a great day.